Hey, I'm Robbie Meyer, the Architect's Concierge for Golden State Lumber, and in 2008, then Governor Arnold Schwarzenegger challenged the California Energy Council to attain net zero energy consumption for all new residential construction by the year 2020. And here we are, mid-2019, with the Terminator's assault on the future dead upon us. I've been trying to figure out a clever way to cut in the governor's tagline, "I'll be back," but it just doesn't seem to fit anywhere, especially when the only thing that you care about is how will this new Title 24 amendment affect my new home designs. Well, for starters, everybody's getting solar. Yay! Whether you like it or not, it's now in the code. If you're building a new house in California, it's going to have solar panels on it. How much solar depends on the house. The bigger or more inefficient the house, the more power it will consume, the more solar you'll need to replace that energy back to the grid to comply with the Terminator's net zero initiative. So it seems reasonable to think toward minimizing the amount of energy our homes consume in an effort to reduce the amount of solar energy our homes will have to generate. And I think that's really the driver here, because along with photovoltaic requirements, there's also new sections of the amended code pertaining to the performance of the thermal envelope. What's the thermal envelope, Robbie? Well, I'm glad you asked. All parts of the structure that maintain a temperature different from that of the outside temperature is considered the thermal envelope. So the exterior walls, the ceiling, the floor. Last month, I showed you a window made from fiberglass. It's one new tool in the designer's quiver to improve that thermal performance. But where else can we combat this energy-sapping villain? Well, how about the walls those windows are installed in? Traditional wood framing is still the accepted best practice in residential construction. There's plenty of alternatives. Structural insulated panels, insulated concrete forms, even rammed earth, all viable options. But traditional wood framing is still predominantly the best accepted practice for building walls. It consists of the exterior cladding, the siding, it's either wood, fiber cement, or stucco in most cases, then the water-resistant barrier, the exterior sheathing, the studs and insulation, the sheetrock, and interior finishes. A typical assembly of a 2x6 wall like this generally gives us an insulation R value at around R18. To improve upon this, of course, the first thought is just get better insulation, and ground's been made here with rock wool and spray foam and the like. We're even seeing insulation sheeting being used outside the wall, up to 4 inches thick in some applications. And yes, that's one route to go. More insulation outside the wall assembly definitely reduces the thermal conductivity of the wall assembly, but it adds a whole bunch of challenges with the attachment of the exterior siding, hanging on foam, and the placement of the doors and windows. Trying to waterproof it all, there's got to be a simpler way. Putting some thought into the makeup and remembering something I mentioned last month, the thermal breaks being isolating the exterior heat from the interior heat. Well, if we could thermally break a window to increase performance, why not the wall that window is in? Makes sense, right? Introducing the T-stud. A revolutionary new take on wall studs that insulates the framing members with the same concept of a thermal break in an engineered product boosting higher strength than traditional wood studs, along with a much higher insulation value by simply breaking the primary thermal bridge of the wall, the stud itself. Just by simply using these studs, your wall assembly R value increases to 16%, by 16%, to nearly R22, with the same insulation. Go to rock wool insulation and get to an R26, almost a 40% increase. Even higher with spray and foam, and not really changing the traditional makeup of the wall assembly. Just substitute one stud for the other. They can be shipped unfoamed for spray and foam applications, or foamed with use in bats. Now, this T-stud's a developing technology, and I admittedly don't have all the data as of today. I'm going off website information and filling in the gaps, and there's a lot to learn here. Something to think about for sure as we go further and further down the rabbit hole of advanced building in the name of energy efficiency. It only makes sense to try to do so simply, and I think changing the studs and thermally breaking the wall is definitely a simple step in the right direction. For more info on the T-stud, click the links below. If you'd like a sample or want to pick my brain about all this, or how I think passive house building principles are the blueprint to kicking net zero straight in the nuts, feel free to reach out. There's a lot to discuss as change is happening fast in the construction industry out west. Thanks in part to a weightlifter turned actor becoming a governor that tossed a gauntlet in a state he ran for a minute, then disappeared. But don't worry.
I'll be back.
I'm Robbie Meyer, the Architect's Concierge from Golden State Lumber, and next month I'm exploring casingless doors. Thanks for watching.